A set is a collection of objects, and an element of a set is an object in the set. So let's take a look at a few sets that we have here. Set A is a set with 5 elements, and those are the elements 1, 2, 3, 4, and 5. So we can say that 3 is an element of set A. Set B is a set with 4 elements, and those are the letters A, B, C, and D. Set C is set C is a set with 3 elements, and those are a picture of a fox, a picture of a panda, and a picture of a tiger. Set D also has 3 elements, and those are the words fox, panda, and tiger. So even though set C and set D have the same number of elements, and we could say set C is a set fox, panda, tiger, and D is a set fox, panda, tiger, they're not the same set, because in set C the elements are pictures and in D the elements are words. In set E, the set is a set of 3 elements, and those elements are panda, tiger, and fox. And since the order of the elements doesn't matter, set E is the same set as set D. And finally, let's take a look at set F. Set F is a set composed of sets. So the objects or the elements in set F are sets themselves. So we have the set containing the number 1, the set containing number 1 and 2, and then a set containing just the number 2. So there are 3 elements in set F because there's 3 different sets contained within set F. Now let's take a look at some notation. One of the symbols that we use in set theory is the symbol is an element of, and that symbol is written basically like this. So it's kind of a letter E that's curvy rather than with straight lines. So you can see here that we have the statement 3 is an element of set A, and that's how we read that. 3 is an element of set A. Now, in this particular set, we do not have the element 7, so we could say 7 is not an element of set A. And so we have the element sign with a line through it. And usually you see that written more as an angled line. In this particular font, it has a straight up and down line. So either way, so it's an E that's crossed out. And we read that as 7 is not an element of set A. So that's what these symbols stand for, is an element of or is not an element of. So it's always talking about something being an object within the set or not being an element within the set. Now, let's take a look again at the set of sets. Here I can say that the set containing 1 is an element of set F because that is one of the objects within set F. Normally, we would not have a set being an element of another set, but this is a special case where our set is composed of elements that are sets themselves. So in those cases, we would have a set that is an element of another set. When working with sets, we often want to describe the relationship between 2 sets. And one of those relationships is a subset relationship. So we say that set S is a subset of set T if all of the elements of S are contained in T. So in this particular case, we have set X, which contains the elements A, B, and C. Since each of those elements are contained within set B, X is a subset of B. And we would write this by writing set X and then using the subset symbol and then set B. And this is what it would look like typed. So pretty much the same. Looks a little bit different. Now, when we take a look at set Y, this set contains the elements A and E. A is an element of set B, but E is not. And so Y is not a subset of B. So I could write Y is not a subset of B. And here we have Y is not a subset of B. Now let's take a look at set Z. Z is the set that contains the elements A, B, C, and D. So we can see that B and Z, sets B and Z, are equal to each other. But we can also say that Z is a subset of B because all of the elements of Z are contained in B. So Z is a subset of B, and we can also say that B is a subset of Z. So those are both true. And when those are both true, that's when you can say the two sets are equal to each other. So that's another definition for equality, just besides for saying that they have the same elements. Let's take another look at our set of sets, F. So F contains 3 elements, and those are the set containing the number 1, the set containing 1 and 2, and the set containing 2. So there are a few different things that we can say about set F. One thing we can say is the set containing the number 1 is an element of set F. If I were to take out that element symbol and write subset, that would not be true. So I'm going to take that and put a slash through it, because this is not a subset of set F, because the number 1 is not an element of set F. So it's a little confusing when we're getting into sets of sets. All right, so what we can see is that the set containing the number 1 is an element of set F, but it is not a subset of set F. Now, what else can I say? I could say that the set containing the number 1 is a subset of F, because now I have one element of set F within a set, so that makes it a subset of set F. So this would not be an element of the set, all of it, just this is an element of the set. So this is an accurate statement. Another thing that I could say is that the set containing the number 1 and the set containing the number 2 is a subset of set F, because now I have 2 elements out of the 3 elements in set F. So those that pretty much covers subset and element symbols. Now I haven't talked about proper subsets, and you can check out your textbook to learn a little bit more about proper subsets.